to everyone. Welcome to the third technical section and fourth general meeting of the proposed Germany branch of NSE. And
If you can hear us, please unmute. Okay.
Yes. So I'd like to welcome us all to today's general meeting and technical section. I would hand over to Engineer Daberechi.
Yeah, good evening, everyone. Wherever you're joining us from, Germany, from UK, especially immediate past chairman from Manchester United, also from Nigeria, all the way from Maiduguri, our immediate NSE past president, in the name of Engineer Ademola Olorunfemi, FNSC. We are happy to have everyone here joining us for our third technical session and our fourth general meeting as well. It's before we know it, we are already 4 months into our regular meetings. We want to thank everyone, for being part of this. We thank our past presenters. We want to thank everyone also for always being part of us. We thank also the team that is also making this possible. The people that are, doing the job at the background, reaching out to our presenters, our moderator as well, our media and the membership team as well. It's been a wonderful time together for the past 3-4 months, and I hope that the weather is not so too warm wherever you are in the UK. I think it's 33 degrees here in Germany where I am today, but we thank God. We want to welcome you to our today's technical session. We hope that it's going to be a wonderful session as usual. We have a wonderful person that we have also invited to be part to present to us today in the name of Engineer Daberechi Agwu. And we hope that at the end of the day, that we will all be happy for taking our time to be here this evening to be part of our technical session. More information, please stay tuned. More information will follow after the technical session. Thank you. I will hand over now to Engineer Oluwatomisi to give us an introduction of our presenter today. Thank you.
Okay, thank you very much, Engineer Daberechi. I would continue from here. I will be reading the citation of Engineer Daberechi Agwu. Engineer Daberechi Agwu is an electrical engineer and energy systems specialist with over 9 years of professional experience spanning renewable energy, power distribution, and electronics engineering across Germany and Nigeria. He's currently a PhD candidate at the Technische Universität Berlin, where his research currently focuses on multi-carrier energy systems, energy management, and energy forecasting. Over the course of his career, Daberechi has managed on-grid and off-grid solar PV installations of up to 729 kilowatts, led performance audits across renewable and telecom power infrastructure, and supported electricity distribution operations in Nigeria, including substation construction and energy metering. He currently works as a software and electronics engineer at Christoph Mitke GmbH and Co. KG in Berlin, where he develops verification systems for electronic hardware. He holds a bachelor's and master's degree in electrical engineering and is a member of several professional engineering bodies, including the IEEE and the Nigerian Society of Engineers. Join me this evening in welcoming Engineer Daberechi Agwu for his presentation.
Thank you very much. So let me share my screen. Share my screen, Windows. Is my screen showing now?
Yes.
Okay, that's fine.
Yes.
Yes,
So
sure.
today, yeah, so today we want to look at multi-carrier energy systems in residential buildings as a panacea for attaining energy security. So, looking at this topic, maybe many things will be coming to your mind, especially starting from energy security. Okay, so first and foremost, we want to use multi-energy system as a panacea for energy security. That says we should look at energy security. And every time when we talk about energy security, I don't know what comes to your mind. Maybe energy security for me is not just for me, for other professionals, is having uninterrupted availability of energy sources at affordable prices. So the key things there when we want to talk about energy security is that the energy has to be accessible and the supply has to be reliable. Like every time we want energy, it will be there, and it also has to be affordable, competitive supply. So that's what makes up energy security. And there are several factors that are affecting energy security. Sometimes natural disasters, natural hazards, they are there. Political instability. We all know what's happening with when it comes to fuel in our cars, Dangote and PMS in Nigeria. They will tell you that they are fighting in Iran. That's energy security, political instability. It has come down to Nigeria. And cost of energy, Nigerians are complaining. So do we really say that we have secured energy? Well, it's subjective. And Nigeria, we are dependent on imports. Yeah. Here in Germany, Germany is also somehow dependent on energy imports. During the Ukraine-Russia war, cost of everything just went up, especially here in EU. It's because of energy. They don't have that energy security. So, and another factor is range of energy resources. Like if there is wind, solar, it can enhance energy security. So, in a nutshell, energy security is very important, and it does not just shape countries' national economy, it also directs global diplomatic relations. I'll give you an example on this. In this Iranian war, I think India says they will still continue buying oil. During Russian war, India also said, no, whatever you are doing, we will still buy Russian oil. So whatever, it shapes diplomatic relationship. So when you think of energy security, just think what is Shell doing in Nigeria, Chevron. They are there just to make sure that some other countries have energy security. So seeing that our energy resources are limited, we must always have to manage the energy. So, and in managing the energy, there's actually two basic approach. It's either we increase the supply or we reduce the demand. Whichever way, to manage the energy, that will bring us to energy management. So there has to be energy. There has to be energy management. So, and in energy management is so essential because looking at the electricity grid, if you have oversupply, the grid will collapse. You have over demand, the grid will collapse. However it is, it just have to be balanced. So, uh, so that's why energy management is very, very important. And either we increase the supply or we reduce the demand. In Germany, Germany approach is both. Germany is trying to increase the supply. That's actually why they have many projects going on, the offshore wind, um, the solar, and if you watch, they're also trying to have increase the diplomatic relationship with Nigeria for gas. And in the news, you will also hear the the Trans-Saharan gas pipeline that will move from Nigeria to Europe to supply gas. This is as an alternative to Russian gas. So they are trying to increase their resources, and in all, they are still forgetting CO2. So here in Germany and Europe, they are not just facing increasing supply, they are also looking at reducing demand. In reducing demand, does it really mean tell everyone, hey, I know you need electricity to cook your food with electric stove, please don't cook. No, not actually. So in managing the demand, that's where the demand side management comes in. So demand side management actually is the planning, implementation, monitoring of activities that influence how consumers use the electricity. And talking about energy, maybe how they use the wood pellets, how they use kerosene as a heating oil, and so on. So demand side management applies to all of them. So instead of increasing electricity generation to meet demand, demand side management actually aims at modifying consumer demand to improve efficiency, how they use it. They have to be using the electricity or energy resources efficiently, and also how they will use it sustainably. So in demand side management, especially when it comes to electricity, there are some balances we use. For example, number one here is peak clipping. So peak clipping is basically, we all know that maybe there's a very high tendency that towards evening, many people will want to cook. And as many people want to cook, the demand for electrical energy in their grid will also increase. So basically for every electrical engineer, especially those who are inclined to power systems, will know about the diurnal calls. So during early morning, like 7, 8 a.m., there's always the demand for energy, electrical energy from the grid will always go higher. And also towards evening, it will also go higher. And then that's for the domestic side. For commercials, maybe from 8, it can go up. From 5 p.m., it will just come down and remain down. So we have peak clipping. We also have load shifting. Load shifting is during that peak period, must you actually cook? Must you actually boil your hot water? Must you actually use the iron? Must you, if it is industries, must they actually operate during the peak demand hours? They can decide, no, I'll pump my water. If it's residential building, I'll pump my water later in the night, or I'll pump it during the midday, something like that. You are actually trying to shift your load. And there's also strategic conservation of energy. Strategic conservation of energy would be, how do I actually reduce my energy conservation, like my energy consumption permanently for real? Let me give you an example. Most of us, okay, let me say in Nigeria, I know many of us like sleeping under the AC, and then while it is fine, some people will sleep under the AC with duvet. They are just living a luxurious life. They have the duvet, they will put on the AC. Okay, if those people actually want to strategically conserve the energy, they'll be like, let me use a light blanket instead of duvet. And then I'll put off the AC or increase the temperature to 25 instead of running the AC at 16 degrees, shivering inside the duvet. That can be a strategic conservation, a decision not to consume unnecessarily. And there are many other examples. So we also have something like flexible load. And that's actually where, if you check the current research topics, you will see flexibility, grid flexibility. So flexible load, flexible load is about load that if I just call you now, hey, don't put on this load right now, you will be okay. nothing will spoil for you. That's flexible load. But if you must use this right now, and if you don't use it right now, things will spoil. I can't possibly tell you not to use it. So that particular load is not flexible. So to make why is this topic actually very important, and why are we talking about buildings? So in EU and also Germany, based on the energy consumption data, the statistics, it has been found that the building sectors, the building sector consume household alone is about 27%, and when you add the commercial buildings, it also increase. So looking at the residential buildings only, which consume 27% of the total energy production in EU, you will see that if the energy is 1 megawatt, 1 megawatt hour, 27% is almost like 300 megawatt hour. That is significant. And now imagine that we talk about the annual energy in terawatt hour, not even megawatts or kilowatts. So, but the interesting thing here is when we come into the buildings, especially the household building, we'll see that the water heating and space heating, or let me say cooling, our air conditioners, just the thermal energy needs is taking about 83.8%. So that says if a building is consuming, let me say, 1,000 kilowatt hour, approximately 800 is used for heating, and that is thermal comfort, and it's huge. So this is what the statistics looks like when we analyze the energy consumption patterns, especially in buildings. So how does it apply to the demand side management resources and measures? So when we talk about flexibility of loads, flexible load and load shifting, valley filling, then we'll see that if we apply energy storage devices like ice storage simply means like during the less peak hours, you can actually put on your ice making machines, your chillers, your refrigerators, whatever makes ice for you, and you store the ice. You can also decide to boil the hot water. Of course, we know our water heaters is very common, and you can also choose to recharge your battery during less peak hours. So it will help you as a demand side person to contribute towards load shifting and making your load flexible. Because if you recharge your battery, that says that if the utility company says, no, don't consume at this hour, you'll be able to just relax, take the energy from your battery. So storages can actually help achieve demand side management. When it comes to energy efficiency, we already know about our energy saving bulbs, and then the latest of the heat pumps. All these energy, using energy efficiently will help us in peak clipping and then strategic conservation. When it comes to strategic conservation, Germany, seeing that the buildings consume like uses 83% of the energy they consume for thermal comfort. Current German law is saying that every building should be insulated. I think you can't build a new building right now in Germany without insulating the building. And for the older buildings, they'll be like, okay, there's incentive, just insulate it. So building insulations, having green roof, they are actually strategic approaches to make sure that we reduce energy. When we talk about green roof, let me say this. I used to tell people like in Nigeria, not just Nigeria, Africa, other African countries, we usually build mini ovens. Why do we build mini ovens? those are our roofing sheets, whether it is stone coated or aluminum step tile, in as much as it is metal, you effectively have a solar converter which converts the solar energy to heat, and it heats up the building. There's no two ways about it. And when people talk about global warming, whatever, yeah, we have stopped building with like our leaves, plant, what do we call thatch roofs? Like we simply move to modern technology, and we are actually suffering the consequences of modern technology. But having green roofs, that's making your planting carpet grass, whatever, on your roof. Having green roofs like this can actually reduce the rate your roof will be converting the solar energy to heat, and so it will also reduce the use of air conditioners. Insulating the roof will also reduce the rate of thermal heaters, whichever way. But the most important thing is that the reduction has to be strategic. So multi-energy systems. As you can see, I have mentioned hot water storage, battery, and so on. Yeah, all of them have been existing, but what do we talk about when we talk about carrier energy systems? It's just trying to find a way to have a combined analysis of all these energy resources with different physics. So normally, as an electrical engineer, I usually have little or nothing to do with specific heat capacity, density of anything. It's always like what's the voltage, what's the current, what's the power, and I'll move on. But right now, when we want to talk about multi-energy systems, it simply means that we are not just going to stop at current voltage capacitance, we are going to go beyond. So a multi-energy system is okay. A multi-carrier energy system is an energy system that produces, converts, stores, transport, and manages multiple forms of energy carriers in an integrated and coordinated manner to improve overall efficiency, flexibility, reliability, and sustainability. So people can call multi-carrier energy systems or integrated energy systems or multi-energy systems, all of them just pretty the same, depending on whatever anybody wants to call. So here in the diagram, I'm just trying to illustrate what a multi-energy systems for us will look like. So one can install solar systems, wind, or take power from the grid. When it comes to the thermal side, one can use the district heating systems, natural gas, wood, and any other forms of energy. One can have battery, chemical storages. One can also have heat storage or ice storage, and there are converters that can easily convert from one form to another. Example, heat pump converting from electricity to cold energy and heat energy. And then you also have things like absorption chillers that can convert from heat to cold directly. So putting all this together and analyzing them together, or trying to create a system where one would depend on the other, is what we mean by multi-energy systems. And if you look in our buildings, yes, we need electricity, we need the cooling energy if we are in Nigeria, and if we are here in Deutschland, we actually need the heat. So there are concepts so far in these multi-energy systems. Some people may choose to specialize more towards district heating systems. District heating systems is coming as a result of trying to improve efficiency of power generation. Of course, gas turbine or other thermal power plants will always produce waste heat. So district heating is just trying to concern themselves on how to recover the heat and distribute the heat to buildings. Other concepts we have is power to heat. power to heat is just saying whenever there's excess renewable energy, maybe wind, solar, we can actually use our heaters to store the energy in thermal storage, in heat storage. So we just basically boil hot water. Some other people will say, no, let us melt stones or store the energy in molten salts. They'll just get salt like sodium chloride or any other salts, trying to heat it to melt it. By doing that, they store the energy there too. So, the truth of the matter when it comes to power to heat is that, yes, we already know we can boil water or whatever, but we are talking about in the multi-energy system, how can we boil, which water will be enough for you to store energy that will last you a day, 2 days, so that you effectively shift your load. Those are the kind of analysis that comes in. So among those concepts also include power to gas. In power to gas, we have hydrolysis. I've been opportune to visit one of the a facility here in Germany that whenever there is excess wind, they are trying to they have electrolysis plant. So when there is excess power, they simply turn on their electrolysis plant and they to start converting the electricity to hydrogen gas through electrolysis. Of course, they also get oxygen, but they said they waste the oxygen. So in power to gas, they basically have to use the excess renewable energy resources, convert it to gas, and take the gas basically hydrogen, to do whatever they need to do with it. So sometimes they will use it to produce synthetic methane. Other times they use it for whatever industrial processes. So among the concepts you will see in these multi-energy systems is directly converting heat to cold energy without electricity in between. And that technology is the absorption chiller. Absorption chiller has always been there. It is not new. But if you go to markets today, you will still buy it. Maybe many of us have not seen it because normal electric fridge has dominated the market, but they are still there. So where one actually wants to maybe store the energy, you have already boiled your water. If you have an absorption system, you can easily convert back the energy you stored in hot water back to cold energy, like use it to chill your room as air conditioner. Yes, it works. So another of the so this is how the absorption chiller works. Basically takes the heat, evaporates the working fluid, and the working fluid, just like our normal air conditioner. That's how absorption chiller also works, but with a slight different technology. So what do researchers do, engineers? What do we do in this field of multi-energy systems? Is basically number one, researching, trying to model. In the building energy systems, we have to, for us to have, let me say, simulation software to decide if I do this is going to be my result. There has to be a lot of modeling. So we need to model what the walls, what would be the walls are the building envelope, wall, ceiling. So what's going to be their model, their mathematical model? Beside that, we also need to model. Look at existing thermal storages, existing water heaters. Are they storing enough? What do we do for it to store more than it is storing right now? Of course, when it comes to planning for like district heating or energy analysis, some other people are advising Deutschland, yeah, you have limited capacity for wind, you have limited capacity for this, you actually need to give people subsidy for building installations. So As researchers, engineers, we have a lot to do, ranging from researching, planning, designing, developing the systems itself. For example, one can choose if the heat storage, the water heating and the heat storage are not efficient. When you research and find out, we can develop anything to improve it. Then we also test and deliver. And above all, whatever is coming from the outcome of the researches forms the policies that will be communicated. So German government, like I have mentioned, what they have been doing, I've mentioned their policies. Of course, one will always hear something like Vision 2050, 2030, renewable energy policies, where they keep making these renewable energy policies. And one of them, like I mentioned today, is we can't build a new house right now in Germany without insulating the buildings, because they don't want you to consume more electricity. They just want each building to have a lower energy consumption. Even if your building is, even if you are thinking, yeah, I won't use electricity for heating, let me use wood. They don't want you to use wood. And they don't also want you to use kerosene heating oil. They just want that energy consumption by buildings to come down. That's policy. That's the decisions. They decide and they make the policies. And they don't just stop there. They also create the legal frameworks to see every new building must be insulated. That means that people who will monitor new buildings or give permits will ask you, show us your insulation plans. They also create they also create incentives, financial incentives for implementing, to say, if you insulate your building, we have so amount of payback we'll give you. Sometimes it can go away from tax, but they are currently doing it. And they also create awareness. The government also creates awareness. This is our policy direction. Hey, everyone, you have to key into this. So in conclusion, when we analyze the energy systems together, looking at the wood, knowing that here in Germany, if you cut down a tree, for that tree to grow back, just give it another 20 to 50 years. Because trees grow here very slowly, courtesy of the winter, leaves will go down, no production, it will just hibernate. So it takes more time to grow trees here in Germany compared to Nigeria. So knowing that we don't want to use all our trees, we don't also want to keep begging Russia or Nigeria, give us gas, give us oil. No. Knowing that also here in Germany, we can't put infinite number of wind turbine. It's not true. The number one, there is a limited land space. Germany has a map. When it comes to offshore, there's also limited. You can't go beyond this. If not, you will enter Denmark or you will enter France. So whatever it is, the energy resources are limited. So knowing that we have all these constraints, multi-energy systems comes in to analyze, okay, you have this so amount of wood, you have this so amount of charcoal, you have this so amount of solar PVs installed, you have this space, this is actually what you are going to do next. So to achieve and maintain energy security, storing energy using other forms beside electricity certainly increases affordability. It also facilitates energy management, which consequently increases availability with little or no resource increase. Storing thermal energy in hot water or ice is suitable for users because humans actually need the hot or cold energy directly for thermal comforts. So, and being naturally occurring, when we store energy in things like hot water, ice storage, it is relatively safe for people and the environment. So with multi-energy carrier systems, So with multi-carrier energy systems, creating models for combined analysis and operations of energy systems with different physics, energy planning, supply management can be achieved with more ease. So multi-carrier energy system is a panacea for achieving energy security, and it revolves around the circle: affordable, suitable, safe, available. All of them comes out to make the energy security. That's it. Thank you.
Thank you very much, Engineer Agwu, for the very wonderful presentation. I don't know if anyone has questions. I haven't checked the room, but I haven't seen any hands up. Are there any questions in the chat? No, I don't see any. So maybe I would start with my own question. First of all, thank you very much, like I said, for the presentation. It was very helpful. But then you made some comment or some notifications about using of hot water, using of AC. But then my question is, are these things not supposed to be normal stuff that we're supposed to be using? For example, we talk about here in the winter, people have to on their heaters, like it's just a normal thing. You can't say, oh, it's a luxury, because somehow I've come to realize that in Nigeria, I feel like every house should have an AC in every house in Nigeria, because the weather is hot. Like the way we have heaters here is the same way we should have like AC. So AC should not be something of a luxury, should be something that should even be included in the building code. Like every house should have an AC, every house should have a running hot water. Hot water should be something that should be a norm. It should be a norm. Growing up here, I didn't grow up like, okay, maybe because I didn't grow up like with hot water and all. Okay, we used to bathe hot water at home. My mom used to, but later I stopped. Then when I started working, I realized that okay, I need to use hot water. But then, so if we look at these things as so much of a luxury and say, okay, because we're trying to conserve energy, we're trying to conserve electricity. Well, I don't know. My own perspective is these things should be the norm. It should not be an exception. Yeah, I see Engineer Ferdinand's hand. So I don't know if you want to answer that question, Engineer Abu.
Okay, so thank you so much for your perspective. It's very simple. How do you feel like there's a war in Iran, and then all of a sudden the fuel pump price moved from I think around 900 to 1,003 stuff. If you are the one to buy fuel, how do you feel? How will you feel? So when we talk about energy security, yeah, we understand coming into your house, looking at the AC, in Nigeria, it's a sign of affluence. It shows that we are doing well, and it's very fine. But when it comes to a country, strategically, we'll start thinking, without Russia, how will Germany secure gas? Will the factories shut down? So when national security comes in perspective, you will see that it will be beyond affluence. And then the question will be, how are we going to help you? Instead of having that AC running it whenever you want, how are we going to help not just you, every other person reduce that energy? And that's where things like building insulation will come in. We'll be like, yes, you have your money, you want to build your house, but you must insulate this building for you to get approval. So when you insulate the building, even if you put your air conditioner to enjoy, you are going to use relatively smaller amount of energy. And that will mean that, let me say here in Deutschland, on overall, they are going to import lesser energy compared to when everybody just use the energy the way they want. If you are in Nigeria, the climate is hot. So what about government saying, hey, everybody, in the name of awareness, we have actually researched and found out that our zinc, your stepstone, step ties, whether zinc, that all those metals are solar converters heating up our buildings. So we want to stop it. So everybody plant carpet grass on top of your roof. What about that kind of policy? Will it reduce the amount of energy, the hours we need to run our air conditioners? The answer is yes. And when we reduce the amount of air conditioners we run, will that our 4,000 megawatts be enough for the whole of Nigeria? Maybe if it's not enough, it will, the number of places it will serve will increase. This is what we mean by energy security, strategic energy conservation. And like I said, it doesn't really mean telling you not to use energy. No, it simply means coming back, sitting down, looking at the drawing board. What is it that is actually consuming most of the energy, and how can we solve it? In Nigeria, green roof is one of them. Thank you. Did I address your question?
Yeah,
Your
thank you very
concern?
much,
Yeah.
Engineer Daberechi. Engineer Ferdinand, if you're there, you can quickly speak up before we take the questions in the chat.
Yeah, okay, thank you, Engineer Daberechi. Your presentation was a nice one and an eye-opener to most of the energy conversation. When we are doing physics, all these things we hear about energy cannot be destroyed.
Created or destroyed, yeah?
Yeah, but it can change from one form to another, So this is the typical explanation of those what we are doing in physics. We did not understand, but now I think it is getting more clearer. So my question is, when you are saying, when you said about if there is excess electricity from the source, maybe it could be solar, it could be wind energy, that some people can also try to melt a, but I know it's a salt compound. You mentioned something like is it sodium or whatever? There is a salt compound you mentioned, but I didn't get it.
That's alternative energy storage. It can be hot water, it can be molten salt. Even if you like, use sodium chloride. Sodium chloride is our normal table salt, whatever. Yeah.
So now my question now is the alternative storage of salt, of energy. When you use salt, if you melt the salt, if you melt the salt, how do you now conserve the energy when you melt the salt? What form can you take back the salt to be used?
Okay, so the concept of multi-energy system is trying to show you that you have different ways to use the energy, and you also have different ways to convert them to any form you want to use it. So coming to the molten salt, when there is excess solar, for example, somebody installed 20 kilowatt worth of solar at home, and by 10 a.m. or 11 a.m., the battery is fully charged, the person is not at home, or the solar energy will waste till evening. I mean, starting from the time battery is full and no load. So if the person is choosing to store it in hot water, molten salt, whichever alternative energy storage that is not that battery, let's take water heater, for example, because it's plenty in our homes. So that person can actually choose to say, let me install a big water heater. If my battery is full, boil this boil the water in the storage tank. That is when the person comes back in the evening, there is no more sun. The person can have hot water to bath in the night and also have hot water to bath in the morning without boiling new hot water using the electricity in that morning or night. So, yes, the energy in the hot water did not convert back to electricity, but that electricity you would have used in boiling a new one if you hadn't boiled that hot water when there is solar available is conserved. It's almost like the electricity you gave back to the grid. Alternatively, there are some, this is also where the research comes in. There are some instruments like organic ranking cycle can actually help you. That's a generator that can work with a lower temperature. Maybe if you have any fluid that can boil at, let me say, 40 degrees or 60 degrees, if you subject it to 100 degrees, that's normal hot water, it's going to boil that fluid, and that fluid is going to get kinetic energy, it's going to turn your turbine. So you are going to convert that heat with your turbine back to electricity. That's when we want to have it in a larger scale. But if it is for buildings, which is the area we are facing in this particular presentation, if it is for buildings, knowing that you want your energy as thermal energy for thermal comfort, whether you are bathing with hot water or you want to make your room have a nice temperature, like there's no point converting it back to electricity. Just use the energy directly from hot water or from ice. So, Engineer Ferdinand, did I answer you?
Moment. Yes, you answered it, but okay. So which means so the salt cannot be, when it melt, it cannot be turned to any form. Just that you have conserved the salt, you have conserved the energy you could have used in melting the salt, right?
Yes. So, before we go ahead, the concept of energy storage is always like substances that undergoes physical change. And substances that undergoes physical change, if you heat them, even if it melts, by the time it cools down, it will solidify again. Do you understand?
Yeah.
You boil water, so the process of heating it, passing through phase change, will store the heat energy, and when you want your energy, you get back your energy as heat energy. So you are going to get your energy as what you stored. If you store electricity in battery, you're going to first of all get back electricity before you start converting it to heat or any other thing, or light with your electric bulb. If you store heat energy in molten salt or water, first and foremost, you are going to get back the kind of energy you stored before you start converting to another form.
Okay.
Okay. I think that answered your question, Engineer.
Now, clear. Thank you.
Okay, so I'll quickly go through the next question. I would like us to be very fast with our answering so that we take note of the time. So the first question is from Engineer Adakole Okwa. It says, thinking of Nigeria, do you see multi-carrier energy systems as a transitional solution until grid reliability improves, or as a permanent component of Nigeria's future energy infrastructure?
Okay, so it should be a permanent stuff. Just like I mentioned, here in Germany, they can easily say, let us continue building gas turbine. Money is not the problem, and they will deliver it within 6 months. In fact, they own Siemens. They know. So, but they have not just increased the supply, like we say in Nigeria, increase. There also has to be management of the one we already have. So it should be like integral part of Nigerian power systems. And sometimes when I say the discos are failing, I mean the electricity companies, whichever one in Nigeria, when I say they are failing, yeah, that's part of it. They're actually supposed to be in forefront of helping consumers manage that electricity so that they will be able to serve a wider area, not just collecting the bill. And somehow it won't take them anything much. So, Engineer Dakole, did I answer you?
Yes, thank you very much.
Okay.
Yeah, thank you very much for the answer. I'll go to the next question from Engineer Adeleye. It says, how does a Nigerian home running on government electricity supply a 4 kV kilowatt solar system on their roof as backup and a 7 kilowatt hour battery ensure energy security, to ensure warm water are readily available all year round, plus cooling with minimal cost.
Okay, that's very fine. It's very simple. This particular one you are seeing here is looking at residential homes. So looking at this diagram on the screen right now, you'll see that for the 7.5 kilowatts, if they oversize their solar panels, if they oversize their PV, the 7.5 kilowatts will get charged very easily. I have an installation in Nigeria. I got it for a friend. 5 kilowatts inverter. So the guy said that by 10 a.m., the battery is fully charged. Yes, it's a 5 kilowatt hour system, and I gave the guy 4.8 something kilowatts. So give or take, maybe if he's producing half within 2 hours or 3 hours, starting from whenever the sun is available, the battery will just by 10:30 is fully charged. And the guy said he works from home. So starting from 10, his air conditioner is always on and he enjoys everything. So the guy has another option, getting water heater. All the water heater they will use to cook in the evening, he can still boil it during the day when there is sun. Another option is getting his freezer, during the evening. If there is heat in this room, just you can go and try it. Get ice block, put it in your bath, leave it in your room. Your room will cool down immediately. It's almost like where you have the high zone, this high zone we have here in Germany, because there's a temperature difference. So they just make sure you leave the ice in a bath, because the water is going to melt and it will just draw off the heat. That's how simple it is, how a residential home can actually apply all this.
Does that
So
answer your question, Engineer Delaya? Okay. So we're taking the last question for the evening. I don't think I see any hands raised.
Yeah.
Or do you have? Okay. Do you want to?
Yeah, thank you, Engineer Daberechi. We're just looking at the conventional water heaters that we have in Nigeria. We are talking of water heaters that are having power of 2,000 kilowatt, 3,000 kilowatt, and if our people are not well informed about the kind of heater water boiler that they need to have in their homes, you cannot just carry a 3,000 watt water boiler and put it on your 5 kilowatt battery, and then you want it to run, to produce hot water for you. So that is, I'm looking at maybe how you can be able to, help our people, to give them, modern concepts of what systems that can be put in place. I understand, the, phase change, temperature change from cold ice, cold water to a warm environment, how, that can affect the temperature of the room, but how we can actually help our people back home for them to know, what kind of, conservative system that can be put in place to ensure that they have, steady warm water all through, and also cool while ensuring cooling as well. Because most of the ACs that we are talking about these days, they are smart with, inverter systems that could run on DC sometimes. And so if people are also aware, for example, that they could also go for, systems that could run on DC and not AC. This could also, help our people to be well informed as well. Thank you.
yeah, thank you for mentioning this. So it all depends on the kind of system you want to run. Running on DC, if you are having solar PV systems, it will not eliminate all the converters in between, because you will still have a buck converter, that's your MPPT charge controller. You are still going to have it in between. Inverter is only there because our normal house uses what's it called again? AC 220 volt and stuff like that. But notwithstanding, the energy losses when it comes to some inverters are up to 98% efficient. So it doesn't really matter whether it is AC or DC, like it's a very short distance your home. It doesn't really make so much difference. But then if there are takeaway our people should take away is that, yeah, I know we actually like affluence, our stone-coated roofing sheet, send down the rain, like you have all those things, yes. They are fine architecturally and they show status. But sometimes, maybe if they want to reduce their energy, when they go to their architect to say, they'll like, yeah, I heard about this green roof. Can you design a beautiful green roof for me? Yeah, that may work. It will certainly reduce the amount of heat that will heat up the building and amount of energy they will require to run their air conditioners. And their fridge, their refrigerators, the efficiency of their refrigerator will also increase because if you watch here in Germany during winter, sometimes for refrigerators that are on thermostat, sometimes they barely come on. If they come on for a short time, they'll stop. But observe that same fridge during summer. You will see that as the environmental temperature increases, the fridge need to work more because as it is removing the heat from inside that fridge, the heat is trying to come back again as transmission heat gain into the fridge. Heat will always move from place of higher temperature to lower temperature. So whatever it is, during winter, heat will want to move away from the fridge, and during summer, heat will move in, and the heat pump, I mean, the refrigerator will have to work more and consume more energy. So in Nigeria, if we have green roofs, carpet grass, making sure we don't just have metal roofing sheets, is going to increase efficiency of the fridge, efficiency of the air conditioner itself, and reduce the amount of energy at any particular point in time. So these are the little things we can actually do. And if we want special water heaters that can like automatically turn on, check, that's where the engineering, research, everything comes in. When I said, what do researchers do? That's where it comes in, research plan, design, and this. So today is just introducing the concepts. There are other things that has been going on.
Okay. Does that answer your question, Engineer Delaya?
Yeah, it's okay. Thank you.
Okay. So we take the last question from Engineer Mubarak as this. When we talk about conservation of energy or management from your speech, does that mean that the idea of band A, B, and so on is a method or just out of plan?
Okay, should I say the truth? If I am in charge of Nigerian electricity, I will not do band A, B, C, D, E, F, G, H. I will not do that. And they did that because they are looking at revenue. They are all interested in maximizing revenue. Sometimes there's a trade-off. When you are thinking about security, food security, energy security, whatever security, sometimes individual interest or company interest may have to go down a little bit. It's just like me telling the moderator, I know your air conditioning is fine. It shows affluence, power, like you have arrived, yes. But sometimes when we want to think about the security of the nation, the energy security, like how a nation will survive, you see that we can make some certain policies to say maybe in residential building, don't use air conditioner more than 1 horsepower. It can come from a research. And so likewise, when it comes to energy conservation, I understand that the distribution companies have profit to make band A, B, C, D, but personally, I won't do that. And it doesn't in any way contribute to energy security or multi-energy systems. That's entirely different thing. It's for profit making.
Thank you very much. In the absence of other questions, I would like to thank you very much for your time.
I don't know, did we answer him, the engineer Mobra?
First of all, it's true. Engineer says, did we answer your question?
Yes, that answered my question. It's just like you say, it's like more of conflict of interest or something like that.
Yes. Thank you.
Thank you so much.
Yeah, thank you very much. So we've come to the point of, I think you can stop the recording for now, and then we can take our group photograph. And then I implore everyone to please